So the displacement equation is very important, but it can be written in a lot of different ways. So one way to write it is like this. 2 pi x over lambda subtract 2 pi ft plus phi 0. Okay, that's one way to write it in terms of the wavelength and the regular frequency. Well, frequency is also the same thing as 1 over the period. So another way to write this is a sine of 2 pi x over lambda subtract 2 pi t over period plus phi 0. And that's kind of a nice way to write it because now they kind of look symmetric. You have position or a length over a length and a time over a time. This is our the length of one cycle. This is the time of one cycle. So that seems a very convenient way of writing it. There's another way that happens a lot, and it is simply a way of making them simpler and thinking more in terms of angular type measurements. So if you take 2 pi over lambda, you can just call that another variable, and we call that k, and it's called the wave number. So that's just simply kx, and again, k is just 2 pi over lambda. So it's got units of inverse length. Okay, actually technically radians per length. And that just simplifies it visually. It's not necessarily functional. And the same thing here, this 2 pi over the period, or even more clear, 2 pi f, that is our angular frequency. And so we have this wave number, which is a radian measure, and we have angular frequency, which is a radian type measure. Then we add our regular radian type measure, our phase constant, how it starts. And that is a lot cleaner. It definitely is a lot cleaner. And a lot of times scientists like to write it out this way. This way is the most functional. You know, period is something we can tell. It's not too different from this because frequency is also something that's very commonly reported. Wavelength is something we can see on a graph. And so this is a more functional one, but you'll often see this. Just remember that k is 2 pi over lambda and omega is 2 pi f, and then remember that f is 1 over the period. So all these ways work depending on what we're trying to solve.